All right, hello everybody. Welcome to week 5, day 1. So last week we multiplied and we divided rational expressions. Okay, this week we are going to be adding and subtracting rational expressions. Okay, so we are adding and subtracting rationals. Our objective, we are going to add and subtract rational expressions. Now, as always, I want you to pause and play where needed. Okay, so we are going to start with simplify the following. And right here, it just says 3/5 minus 2/5. Okay, I started with something we are familiar with here this week because we know that to add and subtract fractions, they have to have a common denominator. Well, 3/5 and 2/5 have a common denominator. So I can go ahead and subtract these. 3 minus 2 is 1. 5 is my common denominator, and so I leave it as 1 over 5. Now, even if I change it so that my common denominator here on B is 2x minus 5, as long as the denominator is exactly the same, I will be able to add or subtract the fractions. So B, I have 10 over 2x minus 5. Plus 4 over 2x minus 5. They have that common denominator, so I can add 10 plus 4, which is 14 over 2x minus 5. Now, some things with adding and subtracting that we need to remember from our multiplying and our dividing. I am still going to say what x cannot be, and x cannot be anything that will make our denominator equal to 0. So on A, there is nothing that x can't be because there is no value for x. Okay, on B, the value that's going to make x equal to 0 is if I set that denominator equal to 0. So 2x, maybe, there we go, equals 5. So x is 5/2. So the value that x cannot be is 5/2. Now, remember, big ideas, when they ask for a value of what x cannot be, it is different than my opinion. Okay, a lot of you heard that as you came into classes last week. My opinion is x cannot be anything at any time that will make the denominator equal to 0. Big ideas will only ask you if you eliminate from numerator to denominator. Okay, so just keep in mind when you're taking a quiz for me that I expect it to be everything, not just what you get rid of. Okay, but the book will ask you for what you eliminate. All right, I will make that known a few times when we talk here. Remember, I cannot, on this question, 14 over 2x minus 5, this is how it stays, okay? We cannot simplify the 14 and 2x because they're not written as multiplication down here on that denominator. It is 2x minus 5, okay? So, what do we do when it says here, let's simplify x squared over 8 minus 3 over 4? Okay, I've started here with the numbers for my denominator because we know how to get 8 and 4 to a common denominator. We know that we need to multiply this by 2. Okay, and I have to multiply by this right here, remember, is called a form of 1. I'm multiplying the numerator and the denominator. Okay, so I have x squared over 8 minus now 6 over 8. On my numerator this time, I have x squared and I have 6. Well, those aren't like terms. So when I subtract, I'm going to leave it as x squared minus 6 all over 8. Now, I'm going to stop right here. I'm going to say there is not a value that x cannot be because x is only on the numerator. Okay, I do not care that x is up here on the numerator. That's awesome. What I care about is what makes a denominator 0, and because there is no x on the denominator, that means x could be everything. I'm also going to stop right here and say, can I simplify anything? Well, 6 over 8, 6 and 8, I can't reduce that because this numerator says x squared minus 6. Okay, it's subtraction, not multiplication. I'm also going to stop here and say, can I factor x squared minus 6? There is a difference. Okay, this is a perfect square. Okay, but 6 is not a perfect square. Okay, so that means that it cannot be factored. This is my simplest form. Okay, Next example. X squared over 5 minus 2x squared over 7. I want you to pause it and I want you to write down what would you need to multiply each fraction, because both need to be multiplied, to get a common denominator. Okay, right there are the form of ones that you would need to multiply on each fraction. So that first fraction, when we multiply by 7, you end up with a 7x squared all over 35. Minus 5, when you multiply that second fraction, you end up with a 10x squared over 35. Now, when we subtract the 7x squared and 10x squared, they are alike this time. So I can take 7 and subtract the 10, so that we end up with the negative 3x squared all over 35. Okay. I'm going to look here. Is there anything x can't be? Nope. X is only on the numerator, so x can be everything. I'm going to look here. Is there any way to simplify if I can? Everything right now is written as multiplication, but 3 and 35 have nothing in common, so that is my simplest form. Next example, 8 over 3x squared minus 5 over 4x. Alright, so when we're looking here, okay, I'm going to write these denominators a little bit different because it's going to kind of help us figure out what we need to have for a common denominator a little bit. This 3x squared has a 3xx, okay? This 4x just is 4 times x, okay? So that 3 was 3 times x times x. Here, I'm going to rewrite that. So it's 3 times x times x. So when I'm looking for, okay, what needs to be common here? I want to see, okay, what does one have that the other one doesn't have? Okay, well, the numbers, that's pretty easy. Okay, the 3 and the 4, well, this is 3 and that's 4. Well, we know that to get 3 and 4 to be the same, I probably have a needed common denominator 12. Okay, so the number part, the number part, is multiplying by 3 on the right fraction, and on the left fraction I'm multiplying by 4. Okay, but that's going to get us a 4 times 3 on this side. 4 times 3 is 12, x squared. 4 times 3 on this side is just 12x. Okay, so because this side has this extra x that the right fraction does not have, that is why we are going to multiply by 3x on that second fraction instead of just 3. Alright? So when we multiply that first fraction, 4 times 8 is 32. 4 times 3x squared is 12x squared. Minus 5 times 3x is 15x. 4x times 3x is 12x squared. Okay, so right here I'm going to subtract, well, 32 and 15 again are not the same, so 32 minus 15x. And if you would prefer to rewrite it with the x first, you may write it negative 15x plus 32, it's the same thing. And then I have a 12x squared here on the denominator. I do have something that x cannot equal this time, okay? X cannot equal, I have an x squared down here, 12 times x squared, so the only value that's going to make my denominator 0 is if x happens to be 0. Okay, I'm going to look here, is there a way to factor in that numerator? There is nothing that 15 and 32 have in common. I cannot simplify the 32 and 12, I cannot simplify the 15 and 12. This is my final answer right here. Okay. Next example. X plus 2 divided by x minus 4 plus 2 over x. And I'm going to tell you right now, because this happens every single time I teach this every year, and if you are a person who thought this, it is a common mistake. Some of you are going to go, oh hey, this just needs a negative 4. But oh hey, that's actually wrong. Okay, so let me show you why it's wrong, so that way you can understand why this does not work. If I try to just do -4, remember this is x minus 4, not x times -4, x minus 4. So if I just times by a -4, I'm going to have x times -4, so that's going to give me a -4x on my denominator, which is definitely not the same thing as that x minus 4. Okay, so that is why, those of you who might have thought that that -4 might have been correct, that is why that will not work. Okay, so what I'm going to look again is, what does that left denominator have? Well, this left denominator has a quantity x minus 4. The right denominator has a quantity of just x. Okay, so what we are going to do is, on that right side, it needs the entire quantity x minus 4. Okay, on the left fraction, okay, it has x minus 4, but it needs just an x. All right. When you multiply these together, I'm going to tell you, keep it simple. And when I say keep it simple, your denominator, you don't have to distribute the denominator. Okay? Denominator, you can leave it as x times x minus 4 on both of them. X times x minus 4. There is no need to distribute the denominator. On the numerator, it is going to help you distribute, because you're going to be able to combine some like terms. So I'm going to make sure this x, because it's times both of those, is x squared plus 2x. I'm also going to do the same thing with the 2, because it's multiplied by that quantity. So 2x minus 4. Alright? So to simplify this here, I'm going to look, okay, I have an x squared. Any other x squared on the numerator? Nope. So x squared. I have a 2x and a 2x, and I'm adding, so I have a 4x. And then I have this -4. And then I'm going to put it all over, okay, that denominator of x times x minus 4. So I'm going to stop here before I do any simplifying of any kind. What can x not be? Okay, well right here. X cannot be 0 because of this x. Okay? X cannot be 4 because of that x minus 4. Alright? I'm going to stop here and say, is there anything on the numerator I can simplify? Meaning, can I find a way to simplify x squared plus 4x minus 4? There is nothing that multiplies to -4 and adds to +4. Okay, so it cannot factor. I cannot simplify numerator to denominator because the numerator is not written as multiplication, so this becomes our answer. Alright? Hey, thanks for hanging in. If you feel like after this you have a lot of questions, remember there is that option to fill out the link for tutoring for today, on Monday. So have a great week.